In this video, I'm going to introduce you to C# and explain to you how it is different from Lua and Python and some other languages that you've seen. But you've already seen Lantern, and that uses C, which is very similar. It's a subset of C#. So you've already kind of seen this before. C# is the distant descendant from a very old language called C, which has been around since 1972. C was used to write the Unix operating system, which later kind of morphed into Linux. And most of the Linux kernel is written in C, and it's only now starting to get replaced by other languages. Now, C had a lot of limitations to it. So about 10 years later, Bjarne Stroustrup implemented a new version of the C language, or a superset, called C++, which introduced the idea of object-oriented programming. Now, C++ has a lot of problems, particularly with the syntax is ugly, but also memory leaks and memory corruption. So it's not a perfect language by any stretch. And then in the 90s, Sun Microsystems attempted to kind of take what was good about C++ and clean that up into a new language that had a garbage collector and better memory allocation and all that. So Java is very, very widely used. And then Microsoft looked at Java and they said, you know, that's pretty cool. We should try to make our own version of that. And they actually made a language called J++, which went nowhere. And then they tried again with a language called C#. And that has been very successful. So C# and Java are nearly identical as far as their syntax. They use different libraries, but if you've seen Java, you will recognize C# immediately. So what are the major differences between C# and Lua and Python? Well, C# is what we call a strongly typed language, and I'm going to go into a little bit more detail on this in the next slide or two. C# is strictly object-oriented, which means all of your code, all of your functions have to go inside of objects. You can't just have code out in the middle of nowhere. You can't have functions out in the middle of nowhere. The language enforces organization on you. You have to create objects, and then you put your functions into those objects. We don't have indentation anymore. We don't have to, like we did in Python, and we don't have like then and end. We don't have those weird keywords like we did in Lua. C# uses curly braces to group code together. So I think the syntax is a little bit cleaner. We're going to have to end our statements with semicolons. Python and I can't remember if Python requires that. I don't think it does. Lua does not really care one way or the other whether you put semicolons on the end of your statements. In C#, you have to end your statements with a semicolon. And again, if you've seen Java before, you will recognize where C# came from immediately. Now, don't freak out because a lot of stuff stays exactly the same. The concepts all stay the same. The syntax will be slightly different, but all of the concepts are the same. We're still going to have variables. We're still going to have control flow. That is, if statements, if-else statements, if-else, I'm thinking else-if statements, yes. We are going to be creating objects. We are going to put our functions and our variables into entities, which we're going to refer to as objects. And we kind of did that in Lua, making, our alarms were objects. We're going to use looping structures to repeat operations. We're going to be breaking up our code and putting that into functions to organize our code. All our code has to go in functions. And we're going to be using collections, like things like lists and dictionaries, ways to store groups of objects. So all of that stuff we've done before. We did all of this in Python. We did all of this in Lua, and we even did a lot of this stuff back in Lantern. So let's move on to this strongly typed language bit here, because that's going to be one of the first things that we run into as that's going to be different. In Python or Lua, when you need a variable, you just write the name of the variable and assign it a value. And you don't have to specify, you don't have to worry about what type of data that is, and that thing can change. So we could make a variable called health and assign it the number 100, and now health has an integer. We could assign it health inside of quotation marks. That means text. So now health is containing a string. And then we could assign 50.5 to health, right? Now this is a number with a decimal point. This is a floating point number. So what health is storing has changed with each one of these operations. Here it's an integer, then it's a string, then it's a floating point number. That works in Python, it works in Lua. That is not how C# and Java work. And when you declare a variable in C#, you have to say what you're going to put into that variable. So for example, if you want a variable called health, you need to specify that that's an integer variable or a floating point number. You have to say what goes in there. If you want to have a variable called first name, you need to specify that that is going to contain a string, which is just a computer used for text. All right, so let's look at the primitive data types that we're going to be using for our variables. To store whole numbers, we have int and long. Most of the time we'll be using int. An int is just an integer. It's a whole number, a number without a decimal point. If you want your health, usually like in a game, health, somewhere between 0 and 100, that's an int. Lives, it's either like 1, 2, or 3, or 0. That's an int. If you need a really, really big whole number, that's a long. Floats and doubles are numbers with a decimal point. Floats they use less storage space than a double, so a double has a bigger range of values that it can store, but they both do the same thing. So a double gives you more precision than a float. Is there any reason to use one or the other? Not really, they're both fine. If you just need a single letter, like the letter A, that is a char or a char. Call them chars, but there's a religious war about that. So that's a single letter. And what about text? Well, that goes inside of a variable type called a string. So these are the 6 data types that we are going to be using a lot. Maybe char, not so much, but certainly ints and strings and probably floats and doubles a fair amount. So these are the primitive data types that we just have to get used to using. Now let's take a look at how we would use them. So in this example, in this first line, I have int health equals 100. I'm saying, hey, I need a variable called health. It is going to store an integer, and I'm going to put the number 100 into it. This is reserve me enough space for an integer, refer to it as health, and put the value of 100 in it. Now, in this next example, I have a long, and why do I have a long here? Well, because 7 million fits into an int. There you go. We're going to change that to 7 billion. 7 billion is too big to fit into an integer. So we're going to put it into a long. But they both kind of do the same thing, and we're not going to ever be needing numbers that are this enormous, so ints are fine. To declare a floating point number, or a number with a decimal point, you just say the word float. Reserve me a floating point number called temp and put the value 98.6 into it. And you have to specify this f after it. If you don't, well, then the compiler thinks it's a double and it's too big to fit into a float. So the f says, hey, this is a float. You are not going to run into this problem very much, so don't really stress out about it. Floats and doubles are basically the same thing, just doubles give you more precision. So if you wanted to have pi or something, 3.1415, whatever, here it is as a double. Make me a double called pi and put this value into it. And again, here we have char. That's we put the letter E into it. So single quotation marks is for a character, a single character. And if you want text, that's double quotation marks. Actually, I need a semicolon there. So make me a string called last name and assign it the value of Baggins right there. So that's all. This is all you have to do. This is all you have to do when you create a variable. You need to specify what type of data goes in that variable and probably give it an initial value. Like if you create int health and you don't put equals 100, it's going to default to 0. Now, you only need to do this when you create the variable. Once you've created it, then we're back to like we did in Lua and Python. We don't have to keep saying this thing is an integer. In this example here, we're making a variable called score, which contains an integer, and setting it to 0. Make me an integer called score equal to 0. Okay, great. Score equals score plus 1. We've added 1 to score. Score equals score minus 5. We've subtracted 5 from score. Oh, and guess what? We need semicolons there. All right. So this should look very familiar. We've been doing this in Lua. We did this in Python. Once we've declared our variable and we've said what goes in it, then we don't need to keep specifying that or keep stating that. Then we're back to working with variables like we've always been working with variables. So I'm gonna kind of pause here. We're gonna call this a day. That's what you need to know, at least as far as variables go, that there's certain types that are reserved by the language, and when we create variables, we just have to specify what goes in there, and that's different from the languages that we've seen so far. So that's the first major difference there that we've seen, is we have a strongly typed language, meaning we have to say what goes into our variables, and that type can't change. So we're going to call it a day here, and then in the next video I will probably go talk about functions and how they work, because they are affected by this strongly typed issue as well.